So today we're going to be solving another problem from the Berkeley integration B, that is this integral from 1 over e up to e of the arctangent of x by x with respect to x. Love it. So how do we solve this guy? Well, first of all, I'd like to make myself a u-sub here. My u-sub is going to be x equal to e to the power of u, just to, get rid of those goddamn bounds there. So I'm gonna get my dx equal to e to the power of u du. As the bounds of integration, well, whenever x is equal to 1 over e, u is going to be equal to -1, and whenever x is equal to e itself, u is going to be equal to 1, and so that's gonna be my u sub here. And the resulting integral is as follows. It is the integral between -1 and 1 of the arctangent of e to the power of u divided by e to the power of u, however, times e to the power of u du as well. I can just go on and pretty nicely cancel out those e to the u's from the numerator and the denominator, and what I'm gonna be left with is just this integral between -1 and 1 of the arctangent of e to the du. Awesome. And so, well, now, yeah, we have so much bounds, but arctangent, yeah, is odd, but e to the -u, it is not odd. So, unfortunately, this integral is not going to be 0, it's going to be something else, and we will have to find it a little bit of a different way, yeah? So how do we do it? I would like to use a pretty interesting trick now. So I'd like to make myself another u sub. Maybe this time I would like to say it's gonna be a t sub, for example. I would like to set my u equal to -t. Yeah, so that's pretty, how to say this? Pretty easy. So it's gonna be du equal to the negative of the dt, and as to the bounds of integration, well, whenever u is -1, is -1, my t is going to be 1, and whenever u is 1. Quick disclaimer here, if you have any problems that you would like me to make a video on, then just hit me up on my Instagram DMs. I'm waiting for you. I just love getting problems from you guys. And now back to the video. My t is -1, just like this, and so my u sub then will give me this integral between 1 and the -1 of the arctangent of e to the -t and then -dt. Use the negative sign right over here in order to flip those bounds of integration. I'm gonna get -1 here and +1 there, and I'm just gonna delete those parentheses here. Okay, well, that's pretty interesting because I can just as well write this thing in the arctangent as 1 over e to dt. Okay, well, that's nice. So I would like to make a trick there. So those both integrals are definite. I mean, they are both just numbers. I mean, eventually they're gonna become just numbers when I evaluate them. Well, eventually, someday. And so I can just integrate with respect to whatever variable I please. I mean, I can just as well replace this t right over here with a u. It will not change the value of the eventual integral, so it's gonna be my 1 over e to the power of u, and I will also change the t to the du. Nothing will change here. You can just interpret it as a u sub once again. It doesn't really matter how you interpret it. And now I'd like to say that both of those integrals are equal to some I. And well, that is true. I mean, both of those are equal to the same number. I just will go between those two by a very easy t sub, yeah? So I would like to add those two up together. I just move this guy here to the right, and I would like to add those two together. Oh no, it's not a straight line. I would like to add those two up together like this. What I will get on the left hand side, because I want to flip it, is double the I. And then I'm gonna get on the right hand side, combine those integrals, because well, those are the same bounds, nothing really changes there, is going to be an integral between -1 and 1 of the arctangent of 1 over e to the u, and then plus the arctangent of e to the u, and all is going to be du. And well, why is it awesome? Because I have this lovely trig property, which is that the inverse tangent, I'm gonna write it in the faster way, the inverse tangent of 1 over theta plus the inverse tangent of just the theta is always comes down to pi by 2. And so I can rewrite this entire integrand here as just pi by 2. This will mean that 2 times the integral I'm looking for there is going to be the same as the integral from -1 up to 1 of a half of the pi with respect to u. That is just pi itself, but if 2 times I is equal to pi, then I is equal to pi by 2. That was a rhyme there. And so I is equal to, I want to be constant when I call this. Yeah, green is gonna be awesome. Pi by 2, and this is the answer. Hope you guys enjoyed it. See you in the next one.